Hi, ladies and gentlemen. Today we're gonna be doing physical science, paper 1, adapted from November 2015. Okay, we'll be tackling question 4. Okay, it says a bullet of mass 20 gram is fired from a stationary rifle of mass 3 kilograms. Assume that the bullet moves horizontally. Immediately after firing, the rifle recoils or moves back with a velocity of 1.4 meters per second. Okay, here we have to identify what we are given. We are given the mass of the bullet as 20 grams, and now remember, we have to have the same units, and with paper 1 we have to use, with physics we have to use SI units of kilograms. Okay, so we have to convert it to kilograms. Therefore we divide by 1000 and it gives us 0.02 kilograms. And then we also given the mass of the rifle, which is 3 kg or kilograms. We given the velocity of the rifle as 1.4 meters per second, and we given the initial velocity of the system, which, because they say stationary, then stationary, it means there is no movement, therefore it's 0 meters per second. Okay, before we can get to calculation, we have to identify which direction we take as positive or which direction we take as negative. In this instance, I always like to take right as positive. Okay, taking to the right as positive. Okay, we know that the equation for momentum is total momentum initially equals to total momentum finally. Okay, here we have mass of the bullet plus mass of the rifle. Because they were together initially, the bullet was in the rifle, and then times the velocity of bullet and rifle equals to, now they have splitted. We have the mass of bullet and velocity of bullet plus mass of rifle times velocity of rifle. And then from here it's just substitution. Mass of bullet 0.02 plus mass of rifle 3 kg, velocity initially of mass and rifle of bullet and rifle was 0, equals to mass of the bullet 0.02, velocity of the bullet is what we want, mass of the rifle still 3, velocity it's 1.4 meters per second. Now remember, they said it recoils, moves back, therefore it's going to the left, then it's 1.4. Therefore I'll just skip some steps, then you can calculate everything here. I'll just write a velocity of bullet as equals to 210 meters per second to the right. Remember, to the right is positive. To the right. Okay, moving right along. The bullet strikes a stationary 5 kg wooden block fixed to a flat horizontal table. The bullet is brought to rest after traveling a distance of 0.4 meters into the block. Meaning that the bullet has traveled a distance of 0.4 meters inside the block. Okay, with reference to this diagram, we must calculate the magnitude of average force exerted by the block on the bullet. Now remember Newton's third law. If body A exerts a force on body B will also exert a force on body A, but in opposite direction. Equal in magnitude, but opposite in direction. Okay. Here we know that average force F net is equals to MA, but we don't have acceleration. We have mass, we want force. Therefore, what we can do is we have the initial velocity. We have the initial velocity as it was fired from the bullet, as 210 meters per second. And then we have final velocity. Remember, it traveled 0.4 meters into the block, and it was brought to rest after traveling this distance. So it means rest, there's no movement, 0 meters per second. And then we have distance, which is horizontally, is changing x equals to 0.4 meters. Okay, from here we can use the equations of motions. See, the final velocity equals to initial velocity. Final velocity squared equals to initial velocity squared plus 2 acceleration change in x. Therefore, we substitute everything. Acceleration, we're looking for it 0.4, and then 0 squared is 0, 210 squared. Okay, I'll skip this step and then you'll calculate the steps. I'll just write the final answer as acceleration equals to 55125 meters per second squared. Okay, remember it was brought to rest, meaning there was deceleration in the block. Now we can substitute everything on this formula. We know that the mass of the bullet is 0.02 times minus 55,125 is equals to negative 1102.5 newtons. Now remember, this is the direction. The bullet is going in this direction. The bullet is going in this direction. Okay, and then it exerts a force on the block. The block also exerts equal force but opposite in direction to the bullet's force. Therefore, the question says calculate the magnitude of average force exerted by the block on the bullet, meaning we're looking for this force. Hence, negative, it's going to the negative side or to the left side. Yeah, okay. Then that is it. Please guys, don't forget to subscribe. Don't forget to subscribe for more videos. And don't forget to comment with your questions so that we can get to answer your questions on the next video. Thank you very much for watching, guys. Take care. Until next time.